Our goal is to solve the following differential equation. First of all, we can write this as dy over dx equals to 2y plus 3 to power 2 divided by 4x plus 5 to power 2. We can do a little bit of algebra and simplify this further. Well, let me choose a different color. You can write this as dx divided by 4x plus 5 to the second. And on the right-hand side, you can write this guy as dy divided by 2y plus 3 to power 2. Since it's a separable differential equation, we can take the integral. When you're taking the integral of the both hand sides, you have to apply u sub method. Substitution method. For example, u can be written as 4x plus 5. du is 4 dx. We can also take v to be 2y plus 3, and dv is equal to 2 dy. Very good. Your first integral is equal to the integral of, here you have du divided by 4 over u squared, and on the right hand side you have the integral of dv divided by 2 v squared. Again, from calculus, remember that the integral of dx divided by x squared is negative 1 over x plus constant of integration. The integral on the left hand side can be written as negative a fourth times 1 over u. The integral on the right hand side is negative a half times 1 over v plus a constant of integration. Now you can multiply everything by negative 4 and simplify this further. So multiply everything by negative 4. On the left hand side, you end up with 1 over u, and on the right hand side, you end up with 2 divided by v plus negative 4 times c. You can call this guy c sub 1 if you want to. And then your integral is equal to 1 divided by my u is equal to 4x plus 5. And on the right hand side, I end up with 2 divided by v, which is 2y plus 3. And then we can call this c sub 1. No one stops us. Very good. At this point, to simplify this in terms of y or isolate y on one side, you can do multiple things. You can basically bring c1 to the other side and flip these two, or you can multiply by 2y plus 3, bring everything to one side. It doesn't matter which algebra method you're using, but you can write this as 2 divided by 2y plus 3, and on the right hand side, you have 1 over 4x plus 5 minus c sub 1, and I'm going to call that guy c sub 2. Flip these two fractions. So you have 2y plus 3 divided by 2 equals to, if you take common denominator between these two, it becomes 1 plus c2 times 4x plus 5. Close up the parentheses, divide by 4x plus 5, and then flip this fraction, so you get equal to 4x plus 5 divided by 1 plus c sub 2 times 4x plus 5. And now you can simplify this by multiplying everything by 2, and then subtract 3, and then divide by 2. So let us multiply by 2 first. You get on the left-hand side 2y plus 3, and on the right-hand side, you have 2 times this fraction. I'm just going to copy down whatever I have here. 4x plus 5 divided by 1 plus c sub 2 times 4x plus 5, and then subtract 3 from both sides. Eventually, you need to divide by 2 as well. So 2y is equal to 2 times 4x plus 5. I'm just going to copy down this guy here, plus c2 4x plus 5 minus 3, and then divide everything by 2. So you can isolate your y on one side. Y is equal to, when you divide by 2, you can get rid of this 2 as well. So 2 divided by 2, just going to write this later to avoid any confusion. So here you get on the right hand side 4x plus 5 divided by 1 plus c2 4x plus 5 minus 3 halves. So you isolated y on one side, and this is the family of solution of this differential equation. We can do more algebra and simplify this further, but that's it for now. Your y is isolated on one side.